Given the functions 1 over x plus 3 and x squared minus 4x, so again, I'm going to sort of color code these, this one in green, this one in blue, and think about how I would graph those. Well, a 1 over x plus 3 graph, that's your 1 over x graph moved 3 to the left, so you could use transformations for that. It has a non-permissible value at -3, so there'll be an asymptote there. So using transformations, 1 over x was one of our parent graphs. So you could just take that parent graph of 1 over x. Whoops. Yeah, that's good. And shift it 3 to the left. Or you could use what we learned in Chapter 2 in our rational functions unit and say, I know I have a non-permissible value at -3. That's going to be a vertical asymptote. I know that the degree is larger in my denominator, so I know I'm going to have an asymptote at y equals 0. And then I could plug in some points to find out where the graph would be. So now, for 1 over x plus 3, you have 2 chapters that taught you how to graph that, and you can use techniques from either of those chapters. Either you have your 1 over x parent graph memorized, and you can shift it 3 units to the left, or you can use your Chapter 2 rational function skills to graph it. For g of x equals x squared minus 4, what I would do to graph that one, probably the easiest thing I can see, is I would quickly factor out the x and see that I have an x-intercept at 0 and 4. And since it's a positive parabola, I know that it is opening up. If I plug in 2, because that's right between those, I would find out that my vertex is at 2, -4. So I'm not using transformations to graph that because it's not just an x squared graph plus or minus something. I'm using some of my skills from graphing quadratics from grade 11. So those are the 2 graphs, and what we're going to do is we're going to do f of x first, which is our rational graph, and then we're going to throw our rational graph into our quadratic. This time it doesn't ask us to graph them. It just says find an explicit equation. So a reminder, what does explicit equation mean? Explicit equation means that we're going to find that equation just in terms of x. And then we're going to find the domain. So in A, g of f of x is equal to g of, and I would have 1 over x plus 3. Because that's what f of x is. And g of 1 over x plus 3, well, your function g is telling you whatever you put in, it'll get squared, and then you'll subtract 4 times that. So if I put in a 1 over x plus 3, that 1 over x plus 3 will get squared, and then I'll subtract 4 times that 1 over x plus 3. And this is an explicit equation. It's only in terms of x. So g of f of x, on the left-hand side, there's our explicit equation. What's its domain? What you have to do to figure out the domain is ask yourself, are there any non-permissible values? Did we have any non-permissible values anywhere from the start of our equation to the final explicit equation that we have? Yes. Our domain x can't equal -3. We'll do the same thing in B. In B, we're doing f of g of x. And since g of x is x squared minus 4x, this is f of x squared minus 4x. Now the function f says whatever you plug in, you do 1 over that value plus 3. So if I have f of x squared minus 4, that's what I'm plugging in. It's going to equal 1 over x squared minus 4x plus 3. Now to figure out my domain here, I'm looking throughout all my equations. Notice in the first line, there is no non-permissible values here. There's nothing that's non-permissible, nothing that's not allowed. But here, in the second part, I could be dividing by 0. How would I find the numbers that might be there on the bottom that would divide by 0? I would need to factor. So if I factor the bottom, x minus 3x minus 1, I can determine my domain x can't equal 3 and x can't equal 1. But x could be anything else. I'm going to combine the practice questions for this one with the next example. So we're going to do one more example together, and then I'll give you time to work on all of them.